So when scientists started looking at beta decay and doing the maths, just like we've been doing in the last couple of questions, they noticed that so you have a radioactive element, it spits out a beta particle, okay? So it turns into another radioactive element plus a beta particle, okay? Now, a beta particle, remember, is, well, it's one of two things. It's an electron, which has a charge of -1 and a mass of pretty much 0, okay? Or it spits out a positron. So, should I go into that now? Let's just say it is a beta minus, so you end up getting an electron out. Actually, put the -1 here and the mass here, okay? What they did then was you'd obviously get energy as well. The beta particle has energy, kinetic energy. So what they did was they looked at the mass of the radioactive element beforehand. They looked at the mass of this, the mass of the electron, and the kinetic energy. They worked out the equivalent energy of the masses. They added on the energy here. And when they looked at the energy on this side and the energy on this side, they were getting a mismatch. Okay? They were still finding that the energy on the right was lower than the energy on the left. And that meant that there was energy going somewhere else and they didn't know where. And eventually a scientist called Wolfgang Pauli, apologies if I pronounced that wrong, proposed that there was another particle, and that particle was called a neutrino, and that the neutrino carried away the energy. Okay? Now, in the same way that you have a positron, which is the antiparticle of an electron, and we'll talk a bit more about antiparticles, you have a neutrino, and its antiparticle is an antineutrino. Okay, so it just so happens that the true situation here is we have a plus a neutrino, an antineutrino, right? Unfortunately, this situation gives you an antineutrino. In the situation where we have beta plus decay, where you get a positron, oops, you get a neutrino. Okay, what is a neutrino? Well, basically, a neutrino is something that has no charge. Okay, and if you think about it, that makes sense because the charge is already added up. So the neutrino has no charge and pretty much very little mass. Okay, so no charge and no mass. Very little mass. It has got mass, it's got very little mass. Okay, so again, it was using the formulas for working out the energy, including Einstein's formula, that ended up in the prediction of this particle called the neutrino. And when a particle has pretty much no mass and it has no charge, it's very hard to detect it. You usually detect things by what you can kind of do to them because they have charge or because they have mass. But eventually they did detect the neutrinos, and I will show you in class. We will go over some videos on how they did this and a little bit more about the neutrino. But right now I just want the practicalities so you can do the homework. So let me just to revisit again, we might as well, in beta decay, right, if you're going to get an electron, if it's a beta minus reaction, if you're going to get an electron, what happens in the nucleus? Remember, one of the neutrons will turn into a proton with the emission of the electron and the antineutrino, as it turns out now. So a neutron turns into a proton and an electron and an antineutrino now. What does that mean about the atomic mass of this? Well, the atomic number as well. The number of protons will have gone up by 1. So it will become a new element that is 1 ahead of the old element in the periodic table. Okay, but its atomic mass won't change because the mass of a neutron and the mass of a proton are pretty much the same. They're both one atomic mass unit. Now, in the situation where you get beta plus decay, you have a proton in the nucleus turns itself into a neutron. Okay, so what impact does that have on the atomic number of this element? It means that it's 1 less proton than the parent. So this will be 1 behind the parent in the periodic table. Okay, that's just a bit of revision. So The main thing is, and the one they speak about the most, is the beta minus decay, but it has come up in the past, so I just wanted to mention this. So in the beta minus decay, to be aware, what happens is, again, a neutron turns into a proton plus an electron plus a neutrino, okay? And energy is given off in the process, because the energy of this mass, when you work out the energy of that mass using E equals mc squared, it is less than the energy of this mass, okay? So there's excess energy given off in the form, and the mass of the electron as well. Even when you add the mass of the electron and the mass of this, it is still less than the mass of this. So there's excess energy, and that's in the form of kinetic energy, mostly of the electron, okay?